Hello, today our group Abdu will be presenting about forecast model of long overdue debtor. There are three members in our group.
Pichayapat Wilairat.
Paulawish Buranakitvisoot.
Sirasit Chiwapong.
Okay, first let's talk about our objective of doing this machine learning. Okay, as you can see on the presentation, there's a news from Bangkok Post. It says that the Ministry of Finance aims to purge bad loans from bureau blacklist, and the ministry is now finding a way to reduce non-performing loans. So we trying to build this machine learning to solve this problem. Our project focuses on building a machine learning forecast model to predict long overdue debtors. Long overdue debts, especially cases exceeding 90 or 120 days, creates serious financial risks for lender and affects credit access for borrower. With rising NPL concerns in Thailand, this prediction problem has become increasingly important. So our group goal is to build a model that can identify potential long overdue debtor early, so financial institution can take preventive action. Okay, there are four processes of our work, which are the raw data, which we got it from the real company, and after we got the real raw data, we just try to clean the data and add some feature into engineering to make it more easier to understand. And the next process is to build and train our own machine learning by using the random forest model method. And after we create and train our machine learning, we will evaluate our machine learning by using the ROC and AUC score.
Okay. To build our forecasting model, we use the random forest classifier. We chose this model because a single decision tree tends to memorize the training data, causing overfitting. But a random forest creates multiple trees using random subsets of data and features. These trees then vote together to make the final prediction. This reduces bias and improves accuracy. Okay. ROC is a graph that shows the performance trade-off of your model. The y-axis shows how many wins you are catching, and the x-axis shows how many false alarms you are triggering. The AUC, which is the area under the curve, is a single grade from 0 to 1 for the model, 1 meaning perfect model, and 0.5 meaning random guessing.
Next, for setting up our environment, to run our project, we create a new Conda environment through the terminal and use Jupyter Notebook to execute our code. This allows us to install external libraries such as Pandas, Seaborn, Matplotlib, and scikit-learn, all required for our forecasting model. So this is the code that we run in terminal. Next, for the data cleaning and splitting. For data cleaning, we applied three main techniques, which first, dropping columns with more than 50 missing data. This column contains too little useful information. Secondly, imputing missing values. For numeric values, we fill them with the median. And for the categorical value, we use the mode. For the feature engineering, we create the new feature to help the model learn better. And that's also including age, which calculates from birth dates, and debt to income ratio, and also the total working months, combining years and month fields. After that, we split the clean data into 80% training and then 20% evaluating to proper test our model.
Here's the timeline of our model development. First, we dropped noisy columns such as shop name that didn't contribute to meaningful information. Then we identified class imbalance because there were fewer overdue customers than non-overdue ones. Then we applied class weight equals balance to force the model to pay more attention to the overdue class. After these steps, we achieved a final AUC score of 63.64%. Then for the final test, we use our 20% dataset named evaluation comprog.csv. This dataset was never used during training, so this ensures that the model cannot memorize the data and gives a fair and realistic measurement of our performance. Our final result is the AUC score of 63.64% and the final accuracy of 84.84%. Thank you.
Thank you.